Look at this question. In the circuit of figure 1, means this one, the three signals of figure 2 are impressed on the input terminals. Means one signal V1 is applied between these two terminals, V2 is applied between these two, and V3 is applied between these two terminals. If the diodes are ideal, then the voltage V output is. Okay, if the diodes are ideal, what is the output voltage they are asking? Anyway, if you observe this, cathodes of all the diodes are at the same voltage. Then the diode with higher anode voltage conducts. Because straight away we are dealing with cathode and anode voltages. Okay. So how to solve this problem? See this. Let me assume some time intervals. First of all, if you see the signals, V1 is like a square wave. V2 is like a triangular wave. V3 is a single pulse. V1, V2, V3. That's what you need to observe. Fine. Okay. Now here I'm assuming some time intervals, like at this particular point I'm taking this interval as t1, this point as t2, next this instant t3, this instant t4, and finally this instant t5. It is 0. Now if you observe V1, V2, V3 over the interval 0 to t1. 0 to t1, V1 is having a larger amplitude compared to V2 and V3. So 0 to t1, diode D1 conducts and the remaining two diodes are off. See, 0 less than t less than t1, D1 is on and D2 and D3 are off. Because V1 is at higher voltage compared to V1 amplitude is more compared to the amplitudes of V2 and V3. Done. So what is the equivalent circuit? When I need not write the equivalent circuit also, it doesn't matter. This acts as short circuit and remaining to act as open circuit. V1, V2, V3. What about V output? It is V1 during the interval 0 to T1. 10 kilo ohm resistor. Next, over the interval T1 to T2, T1 less than T less than T2. T1 to T2, V1 amplitude is less than that of V2. Anyway, V3 is 0. So V2 is greater than V1 and V3, and hence D2 will be on and D1, D3 will be off. D2 is on, D1 and D3 are off. Because V2 is greater than V1 and V3. So D1 acts as open circuit, D2 acts as short circuit, again D3 acts as open circuit. V output 10K, V1, V2, V3. What is our output? V3. Sorry, V2. Next, T2 to T3. T2 to T3, V3 is greater than you see, this is our V3, it is greater than V2 and V1. So D3 is on, D1, D2 off. So open circuit, instead of D1 and D2, I'm writing open circuit, instead of D3, it is short circuit. 10K V3, V1, V2, V output is equal to V3. Next, T3 to T4. T3 to T4 means for T greater than T3, V3 is 0 and V2 is greater than V1. Okay, so D2 is on and output is equal to V2. T3 to T4. T3 less than T less than T4. D2 on, D1 and D3 off. So (10K) V1, V2, V3, V output. So V output is equal to V2. We can write. And finally, T4 to T5. T4 to T5, V3 is anyway 0, V2 is this portion, V2 is less than V1 and hence D1 is on, remaining D2, D3 are off. T4 to T5. Here D1 is on, D2 and D3 are off. So what is the equivalent circuit? It's a very, very simple problem actually. (10K) V output V1, V2, V3. V output is equal to V1. Next, for T greater than T5, V1, V2 are negative and V3 is 0. So there is no point of any diode to contact. Okay, so for T greater than T4, T5, all diodes are off, no diode conducts. Okay, all the diodes are off means what is the equivalent circuit? (10K) V1, V2, V3. V output is simply 0. That's it. Then what is our final output waveform? See, if you observe the options for T greater than T5, output should be 0. So we can discard the options C and D, right? And we can look at A and B. Of course, option B is correct. So here only I am showing the overall output waveform like this. 0 to T1, V output is equal to V1. And T1 to T2, V output is equal to V2. T2 to T3, V output is equal to V3. And again, T3 T3 to T4, V output is equal to V2. T4 to T5, output is equal to V1. For T greater than T5, output is simply 0. So, which is matching? Option B. A very simple question it is. Okay. This is how we can do this problem. Next, see this question. Assume the diodes in the circuit shown are ideal. The current Ix flowing through 3 kilo ohm resistor in milliamperes rounded off to 1 decimal place is. Okay, they mentioned ideal diodes. Let me give some naming, numbering to the diodes. D1, D2, D3, D4, D5. Okay. So first, the moment you see the circuit, we can observe these three cathodes. The cathodes of all the three diodes, D1, D2, D3, are at the same voltage. Then the diode with the highest anode voltage only will conduct. Means D1 conducts, D2 and D3 are off. Very simple thing. And what about D4 and D5? Okay. So I'm just for the sake of better understanding, I'm drawing the circuit this way. Fifteen volts, 3K, this current is Ix. Anyway, remaining two are open, even I need not show that. 10 volts, 5 volt. So this acts as short circuit. I will do one thing. Short circuit. Here it is 12 volts, 6 volts, 2K, 2 kilo ohm. Further, if we observe so, from 15 volts to 12 volts, okay, there is a scope for this diode D4 to conduct. Higher potential to lower potential. Again, 15 volts to 6 volts, if you take D5, the cathode of D5 is going to 5 and its anode is going towards 15 volts. It looks like D5 is also conducting. So we are not sure. It looks like both are conducting. Okay. So assume D4 and D5 are on. But D1, it's not like assumption. Definitely it will conduct. D2, D3 do not conduct. So now I am taking assume D4 and D5 are on. Okay. Then what is the equivalent circuit? Fifteen volts. This current is Ix. 3 kilo ohm, 2 kilo ohm, 2 kilo ohm, 12 volts and 6 volts. Okay. This is what we can take. They're asking us to find Ix. Okay. So it's like looking like some regular network only. So it's not like from this circuit directly we can write Ix. We should see the currents through the diodes D4 and D5. That means ID4 and ID5 I can write, or I4 and I5. We should see that, right, these two currents I4 and I5 are positive. If any particular, if current through a particular diode is negative, then diode cannot conduct. So for that, let me take this voltage as Vx. So how to find Vx? Let me take the node equation. KCL at node X. Vx minus 12 by 2k plus Vx minus 6 by 2k plus Vx minus 15 by 3k is equal to 0. So Vx minus 12 by 2k, Vx minus 6 by 2k and Vx minus 15 by 3k. Okay, done. Vx by 2, Vx by 2. Anyway, kilo cancel, right? I can cancel that, not a problem. Vx by 2 plus Vx by 2, that is Vx. Vx plus Vx by 3, that is 4Vx by 3. It is equal to 12 by 2, 6 plus 6 by 2, it is 3 plus 15 by 3, it is plus 5. So it is equal to 14. What is Vx? It is equal to 7 by 6 volts. We can take it so. Oh, sorry, it's not 7 by 2. 21 by 2, 11.5. Straight away I am writing it because I can write 2 2s, 2 7s. It is a 21 by 2, 11.5 volts. Now, if you look at I4, what we can write I4 or ID4, it is equal to Vx minus 12 by 2k. That is 11.5. Vx is less than 12. So, definitely it is negative value. Implies D4 does not conduct. If a diode is on, current from anode to cathode should be positive, but we are getting negative. It is not possible. Implies D4 does not conduct. So what about D5? Well, definitely you will get Vx minus 6. That is 11.5 minus 6 by 2k. It is positive. D5 will be on. So finally, what we can write the circuit. Our assumption is wrong. So that's how. Even though we are having this circuit, from this circuit we can find Ix, which I have not done so. Before finding Ix, we should conclude that our assumption is wrong. But sorry, our assumption is correct. But here, as our assumption is wrong. I assumed D4 and D5 are on, but only D5 is conducting. D4 is not conducting. Okay. So, what is the final equivalent circuit? Instead of D5, it is short circuit. It is 2K, 6 volts. After that, 3K. This voltage I wrote it as Vx. Next, the diode D1, and before, after that, 15 volts. And the current through this 3K, it is Ix. So, how do we find this Ix? Ix is equal to 15 minus 6 by 2k plus 3k. 11 by 5. So, 11 by 5 means 2.2 milliampere. Sorry, 15 minus 6, it is 9. No? 9 by 5. 9 by 5 means 1.8 milliampere. Ix is equal to. That's it. It's a very simple process. Ix, and of course it is equal to I5 or ID, current through the diode D. So this is the question asked in GATE Electronics paper 2015 given by IIT Kharagpur. Okay, this is the idea. Next, assume that the diodes D1 and D2 in figure are ideal diodes. The value of current I is Now you see what are the polarities of the current source. If you take it is plus and it is minus, then both cathodes of two diodes are at the same potential. Then which anode is at higher voltage? Anode of D1 is connected to positive terminal and anode of D2 is connected to negative terminal. 100% D2 is off and D1 is on. Okay, so here only D1 is on and D2 is off. So what about the current through D2? It is I, which is 0 milliampere. So no current flows through D2. D1 acts as short circuit. Anyway, they asked current through D2. Our answer is A. Just out of curiosity, I'm continuing the things, nothing else. It is 2K, 1 milliampere, and this is ID1. ID1 is equal to 1 milliampere. Okay, so short circuit parallel with this 2K, it is short circuit only. Further, I can redraw the circuit like this. D1 short circuit and 1 milliampere, it is 2K. Whatever ID1 comes, entire ID1 flows through 2K. That is equal to ID1. It is equal to 1 milliampere. Right? It is also possible. See, sometimes they may ask to find ID1. It is simply 1 milliampere. Or current through this 2 kilo ohm, that is 1 milliampere. Such things are possible. It is also a good question. A very simple one.